So guys, so today we will see about the DynamoDB global tables. Okay. So definition says that DynamoDB global tables are fully replicated across multiple AWS regions, allowing you to build applications that serve global users with low latency access and high availability. Okay. So basically, DynamoDB global tables, which means see in this is like a global tables. Those are fully replicated across multiple AWS regions, which means like in all the regions you'll be having these tables. Means replicated table. For example, in one region you deploy a table, that table will be replicated in all multiple AWS regions. Okay. For example, like Virginia, Oreo, Ireland, Mumbai, like that. Okay. So allowing you to build application that serve global users with low latency, access, and high availability. So wherever the application that demands, the global user, for example, like I am here in Ireland, and some people will be in India, and some people will be in UK. So they want to access the application, okay, without any with low latency and high availability. So that time we can go with DynamoDB global table. Okay. So when using global table, read and write operations are automatically replicated across the regions, which brings unique consideration for both read and write operation. So here, both read and write operation both are replicated across the regions. Okay. So we'll see how read and write operation work in global table. So in write operation, when you perform a write operation in a region, the data is replicated across all the other region where the global table is replicated. Okay. The replication process is asynchronous. This means that once a write is completed in one region, it may take a short time to change to propagate to other region. So you write a um, once you write a mm, I mean do a write operation completed in one region, it same takes some time to replicate in the other region. Okay. In the case of conflict, where two regions simultaneously write to the same item. So, for example, change is a global table, right? So, from two regions, okay, so they're trying to do one write operation to the same item. So, DynamoDB uses the last write wins. Okay, so it uses these concepts to resolve the conflict resolution based on a timestamp. So, based on a timestamp, okay. So, we'll see write cost for each region where the global table is replicated. The write operation incurs a write request cost. So a single write in one region results in write operation being performed in all other regions as well. So leading to multiple charges. Okay. In read operation, reads can be performed from the closest region, reducing latency for user accessing the table from a different region. So reads can be performed from the closest region, which means where somewhere like you deploy any, I mean, okay, from people like who are closer to that, they're trying to access it. Okay. So from doing this, you can reduce the latency. You can configure application to read from the region closest to the user, but it, if data hasn't yet propagated to that region, the system might return failed data for application where consistency is critical. You can enforce strongly consistent reads, but these come with the higher latency and cost. So you can configure application to read from the region closest to the user that you know. But if data hasn't yet propagated to that region, for example, do a read, you do one write operation, okay. So that is not propagated to other region. So if you're trying to read that, okay, that region, the system might return stale data for application where consistency is critical. Okay, but you can enforce strongly consistent reads, but this comes with higher latency and cost. Okay, So, read cost, we'll see. Read operations are charged separately for each region. If you're reading from a global table, each read from the region where the request is made incurs the standard DynamoDB read costs. Okay, we'll see some model. Okay, consistency model. So, eventually consistent reads and strongly consistent reads. Eventually consistent range means it's like default. Okay, so DynamoDB global table use eventually consistent reads by default, meaning that it is possible for some regions to return stale data until application is complete. So here I'm telling about the stale data. Is it? Is it? So stale data means like data that is out of date, okay, or no longer accurate. So this is nothing but stale data. Okay. So strongly consistent read means you can enforce strongly consistent reads, ensuring that you always read the most up-to-date data. But this requires reading from the region where the write occurs, increasing latency, which means see you can enforce strongly consistent reads, ensuring that you always read the most up-to-date data. Okay. So you can enforce the system. Okay. But this requires reading from the region where the right cut. So, for example, like there are two regions. In one region, I write okay, but that right operation is not propagated to other region. So the other region, I'm trying to read. Okay. In this case, the propagate data is not happened. Okay. So what in this scenario we can enforce strongly consistent reads so that you can always read the true date data. But this requires reading from the region where the right word. Okay. So this increase the latency, also the cost. But this will be increasing the latency, but it comes with their own standard DB read cost. Okay. So eventually consistent read means by default where even though if you are trying to access, you will get the stale data means no longer available. I mean like something like out of date. So next we'll see fast simply make a right or example use case we'll see. For a global e-commerce application, you can configure a DynamoDB global table so that user in North America, Europe, and Asia all experience low latency access to product data. Each region will have its own copy of the data and updates to products like price changes will be propagated across all the regions. So in simple, we use global e-commerce application, for example, where can configure DynamoDB global table so that user in any regions like North America, Europe, or Asia, they experience low latency access to is the data. Each region will have its own copy of data and updates to products. Where in each region will be they have a data which will be propagated across all the region automatically. Okay. Summary. So DynamoDB global table ensures that data is available in multiple regions for high availability and low latency access. Write operations and are replicated across region asynchronously, while reads can be performed locally in each region. However, the cost structure reflects the replication of data and operation across multiple regions. So both read and write costs are incurred per region. Okay. So Amazon DynamoDB global and local secondary indexes. So in Amazon DynamoDB, indexes are used to improve query efficiency. Okay. Guys, this topic will be in a separate video. So that is all about this topic, that Amazon, DynamoDB, global and local centric. Because I don't want to miss these two topics. So this topic, I will explain you in separate video, guys. So what we discuss in today video is like, this video is like DynamoDB global table. So I hope I try to explain you in simple terms. So in next video, I will explain you Amazon Dynamo global and local secondary index. Thank you, guys.